This section aims to combine all of the derivative rules and formulas that we learned in previous sections. Below you will find a table of examples of functions that we have learned to take the derivative of so far. Please review this table and have it help you do the following examples. Example 1 says, if y equals the quantity x plus 1 over x squared to the fourth power, find y prime. So the first thing that we want to do is we want to use the power rule. So we have 4 times x plus 1 over x squared to the third power, and then we need to multiply by the derivative of the function on the inside because of chain rule, and in order to take the derivative of the inside function, we need to use the quotient rule. So let's see, we'll have the bottom times the derivative of the top minus the top times the derivative of the bottom all over the bottom squared. And let's go ahead and simplify that a little bit. So this, if I subtract x squared minus 2x squared, that should become negative x squared. And if we combine all of that, we would get 4 times negative x squared minus 2x times x plus 1 cubed all over x to the 10th power. And there is our derivative. Example 2 says find f prime of x if f of x equals the quantity x cubed minus 1 quantity squared all over the quantity x plus 7 cubed. So we're going to need to use quotient rule, and we're going to do bottom times the derivative of the top. So for the top function, we're going to have to use the power rule. And then we're going to need to use the chain rule for the inner function, and then do 3x squared. So that is for that portion. So bottom times the derivative of the top minus the top times the derivative of the bottom. So that's going to be 3 times x plus 7 squared. And I could use the chain rule for that part, and then the derivative of the inside, the derivative of x plus 7 is just 1. So it's going to be that. And then I want to take the derivative of the bottom. Excuse me, it would be over the bottom quantity squared. And if I squared that, the new exponent becomes 6 instead of 3. So let's clean up the numerator. If I multiply this 2 with that 3x squared, then we get 6x squared times x plus 7 cubed times x cubed minus 1 minus, let's see, I can multiply this 3 and this 1 together, and that would give me 3 times x cubed minus 1 squared times x plus 7 squared all over x plus 7 to the 6th power. Now, I can factor out an x plus 7 squared from the numerator, since here we have x plus 7 cubed, and here we have x plus 7 squared, so I can factor out an x plus 7 squared. So let's do that. So I'll have f prime of x equals x plus 7 squared times 6x squared times x plus 7 times x cubed minus 1 minus 3 times x cubed minus 1 squared all over x plus 7 to the 6th power. And then I can divide this, and then the new power for that would become 4. So I'm running out of space here. So this equals 6x squared times x plus 7 times x cubed minus 1 minus 3 times x cubed minus 1 squared all over x plus 7 to the 4th power. And there is our derivative.